Okay, good day everyone. Now we are in the formal definition of definite integral, lesson 5.1. Lesson outcomes. At the end of the lesson, the learner shall be able to define the definite integral as the limit of the Riemann sums and illustrate the definite integral as the limit of the Riemann sums. In this lesson, we formally define the definite integral as the limit of these Riemann sums when the number of partition points goes to infinity. We then associate this value with the exact area of the region described above if the limit exists. Again, we work with the continuous positive function y equals to f of x defined on a closed and bounded interval A, comma, B. The objective of this lesson is to find the area of the region R bounded by y equals to f of x from above, the x-axis from below, the line x equals to A from the left, and x equals to B from the right. For example, in this graph, so meron tayong given function y equals to f of x. Then yung ating tinatawag na bounded region under the curve, yun yung tinatawag nating region R. To avoid complications, we just consider the case where the partition on the interval is regular. We recall that the P sub n or the partition is equals to the set of x sub 0, comma, x sub 1, comma, and so on up to the x sub n minus 1 and x sub n, where x sub 0 is the A and x sub k is equals to x sub k minus 1 plus delta x, with a given delta x is equals to b minus a all over n. And the b minus a is the what we call the bounded interval a comma b into n congruent sub-intervals. For each sub-interval, k is equals to 1, comma, 2, comma, and so on up to n, let x asterisk sub k be any point on the kth sub-interval. So we have the closed sub-interval k sub k minus 1, comma, k sub k, or x sub k minus 1, comma, x sub k. Then the Riemann sums defined by this choice of points relative to the partition P is we have the given function of x asterisk of 1 delta x plus f of x asterisk of 2 delta x plus and so on up to the f of x asterisk sub n minus 1 delta x plus f of x asterisk sub n times delta x, which is the same as the summation of f of x asterisk sub k delta x, where k start from 1 up to the n. The class should realize that if this is a set left Riemann sum, then we have the x asterisk k is equals to x sub k minus 1. If this is a right Riemann sum, then we have the x asterisk k is equals to x sub k. And finally, if this is a midpoint Riemann sum, then x asterisk k is equals to 1/2 of the x sub k plus 1 plus x sub k. In any case, we know that above Riemann sum is only an approximation of the exact area of the R. To make this estimate exact, we let n approaches infinity. This limit of the Riemann sum is what we call the definite integral of f over closed interval a comma b. So for example, a given notation, we have the limit of the summation of f of x asterisk k times delta x where k start with 1 up to n, and n is approaching infinity, which is also equal to the definite integral of the f of x dx start from a up to b. And if this limit exists, the value of this integral does not depend on the kind of left, right, or midpoint of the Riemann sum being used. Okay. Remember that the delta x actually depends on n. So we have the delta x is equals to the difference of b minus a all over n. So this term cannot be taken out from the limit operator. After taking the limit, this delta x becomes our differential dx. The integral sign r and the differential dx act as delimiters, which indicate that everything between them is the integrand, the upper boundary of the region whose area is what this integral is equal to. The numbers a and b are called the lower and upper limits of the integration, respectively. So recall that the integral sign, elongated s, was earlier used to denote the process of anti-differentiation. Okay, geometric interpretation of the definite integral. Let f be a positive continuous function on closed interval a comma b. Then the definite integral of the integration of f of x dx, where a lower boundary and b the upper boundary, is the area of the region bounded by y equals to f of x. The x-axis, x equals a and x equals b. Consequently, the definite integral does not depend on the variable x. Changing this variable only changes the name of the x-axis, but not the area of the region. Therefore, pwede nating gamitin yung symbol natin, the integration of f of x dx or a start from a up to b is also the same with the integration of f of t dt start from a to b, and also integration of f of u du start with a up to b. Computing definite integrals by appealing the geometric formulas. Using the geometric interpretation of the definite integral, we can always think of the definite integral as the area of a region. If we are lucky that the region has an area that is easily to compute using elementary geometry, then we are able to solve the definite integral without resorting to its definition. For example, 5.1.1. Find the exact values of the following definite integrals. Ito yung mga example natin. So, integration of 3dx start from 1 up to 3. Number 2, integration of quantity of 1 minus absolute value of x minus 1 dx start from 0 up to 2. Then number 3, integration of 3x plus 1 dx start from 1 up to 3. And the last, integration of square root of 1 minus x squared dx start from negative 1 up to positive 1. So, isasayin natin itong mga natin na definite integrals. Okay, let's start with number 1. The integration of 3dx start from 1 up to 3. Using the above definition of the definite integral, we just draw the region and find its area using elementary geometry. Okay, lagay natin siya sa graph. So pag nilagay natin sa graph yung function, so nandun siya sa 3, then we have y equals to 3. Ito tinatawag natin constant function. Then yung shaded region niya, ito, under the, what we call the function, so itong mayroong red na shaded region, mapapansin natin, it is a rectangle. Then pag kinuha natin yung area, di ba? Length and width. So gamitin natin itong x-axis. So ang kanyang width ay 2, kasi 2 units lang eh. At yung kanyang length naman ay 3 units, start with 0. So meron tayong 3 units. So therefore, length and width is equals to 2 times 3 and it is equals to 6. Therefore, the integration of 3dx start from 1 up to 3 is equals to 6. Okay? Next, number 2 under na example 5.1.1. So based on the graph of this definite integral, so integration of 1 minus absolute value of x minus 1 dx, start from 0 up to 2. So the graph of y equals 1 minus absolute value of x minus 1 is given as, okay, so ito yung kanyang graph. So yung function natin, y equals 1 minus absolute value x minus 1. Then, pag tingnan natin yung area bounded ng function, the shaded region is a triangle with base B equals 2. So, ang base B natin, ito, 2. And the height is 1. Diba? Ang height niya ay 1. So, its area equals to, ang area ng isang triangle ay 1/2 base times height. So, we have 1/2 times 2 times 1 is equals to 1. Therefore, the integration of 1 minus absolute value x minus 1 dx start with 0 up to 2 is equals to 1. Ayan, di ba? Okay, for example number 3, under example 5.1.1, so we have the integration of 3x plus 1 dx. Start from 1 up to 3. The graph of y equals 3x plus 1 is a line slanting to the right. Ito yung kanyang graph, di ba? Ayan, yung black line slanting to the right. So, ang kanyang function y equals 3x plus 1. So, pag tingnan natin yung area bounded ng region, so, I start from 1 up to 3. Ito ngayon yung orange, ito yung shaded region. So, kung mapapansin mo, dun sa ating area, isa siyang pwede natin tawagin na trapezoid. Di ba? Isa siyang trapezoid. So, dito sa trapezoid na to, ang magiging basis natin ay ito yung base 1. At ito naman yung base 2. Ang base 1 natin ay 4 units. At ang base 2 naman natin ay 10 units. Then ang height natin ay 2 units. Ito ang magiging height natin. Yan ang height natin. So 2 units, di ba? So 1 unit and second unit. So ang h natin ay 2. So pag ginamit natin yung formula ng area ng isang trapezoid, we have 1/2 1/2 of base 1 plus base 2 times the height. So we have 1/2 ang base 1 natin ay 4 plus 10 base 2 times height 2. So we have 14. Therefore, the integration of 3x plus 1 dx start from 1 up to 3 is equals to 14. And that's it. Okay, for example number 4 under example 5.1.1, find the exact values. So we have the integration of square root of 1 minus x squared dx. Start from -1 up to +1. The graph of y equals square root of 1 minus x squared is a semicircle centered at the origin with radius 1. Okay, check natin yung kanyang graph. Ayan. So ito ay isang semicircle. Ang kanyang origin ay, ang kanyang center yung origin, then 1 unit ang radius. So that is y equals square root of 1 minus x squared. So pag kinuha natin yung kanyang area bounded under the semicircle, the area of shaded region is 1/2 pi times radius square. 1/2 pi times radius square. 1/2 dahil nga semicircle eh. Siyempre pag buo yan, pi r square. Dahil nga semicircle, so 1/2 lang. Okay? Ang radius natin ay 1 unit. Therefore, kapag kinuha natin ang integration ng square root of 1 minus x squared dx, start from -1 out to positive 1, and that is equal to pi over 2. Yan, pi over 2. Kasi itong 1/2 times 1 squared, 1 pa rin ito. So, times mo lang sa 1/2 pi. So, 1/2 pi or pi over 2. Same lang yun. And that's it.